Hi guys, I thought we'd take a closer look at these Siemens tanks. These are high voltage X-ray generator tanks, or as they're known in the trade, HT tanks. There's a microwave run transformer on there for reference for the size, and these seem to be quite a popular high voltage generator, at least in the UK. So if you guys are going to come in contact with a transformer, it's probably going to be one of this type. So I thought we'd have a closer look at it. Right guys, so I've laid out here in block form basically what's inside the X-ray generator tanks. So as you can see here, these are Siemens tanks. This is the model number of the particular tank in question, the one we're talking about right here, and the operating frequency of these is 6 kHz. It's 380 milliamps at 150 kVs, and that is 57 kilowatts. Now from experience I can tell you that these put out quite a bit more than that. I mean, I've had over 200 kV. I'm not saying it's a good idea to do that. Obviously this is the rating, so we should really stick to that. Now some of these ratings on these caps and transformers etc are from what I'm guessing from my experience with these things. Obviously they're rated at 150 kV, but they would have to have some margin above that. So guys, as you can see, there's two transformers in these, because this is a bipolar supply, and they are referenced to a centre ground, as you can see here. So what we have is two transformers, iron core transformers by the way, and these feed into a voltage doubler on each side, comprising of this capacitor and these diodes. There's two capacitors in each of these, and they're 20 nanofarads, and I'm guessing 50 kVs. So we have transformer, voltage doubler, we have series limiting resistor. This is a 7k resistor, again on both sides, and then we have a resistor for sensing the output voltage. And lastly, we have a filament transformer over here, which is floating, so it has to be insulated up to the full voltage of one side. That's why it's under oil. Now with most of these transformers, and the Siemens is no exception here, we have access to both of the primaries on the outside of the tank. So we could either run these in series or parallel, depending on whether we want to use a half bridge or full bridge to drive this thing. Obviously, if we want to use a half bridge, we put them in parallel, and if we want to use a full bridge, we put the primaries in series. As you can see, they're geared up for 120 volts RMS, which is half of the mains voltage here in the UK. Right then guys, so all these are actually the genuine components from one of these tanks, except of course these transformers. The original transformers are here off to the right, and we'll take a close look at those now. So guys, this is the heart of this unit. These are the two transformers, and as I said earlier, these are iron core transformers, although they do run at 8 kHz. So the only difference is the laminations. The laminations in these are much finer than they would be in a mains frequency transformer, obviously to reduce the eddy currents. So over here we have the filament transformers, and obviously they just put out a small voltage for the filament in the tube, and that's transported alongside the high voltage negative. So I'll show these running guys. I've got this connected up to my half bridge, like I said earlier, 6 kHz. We've got a 14 centimeter gap across here, so we'll just wind these up. Just watch the corona on this, guys, because it's high frequency AC and high voltage, of course. It's incredible. That's amazing, guys. That was about 35 amps, 280 volts on the input side. Right, guys, hope you found this video interesting, and there'll be more to come on these transformers shortly. Thanks for watching, guys. Take care.